Old quiz up.
All right, we are recording.
Hey, Professor, what up?
Well, at least I got 1 and 2 right.
There we go. Progress. Hashtag progress.
I think those are the two I've never missed. Yeah.
Oh, I've missed him a couple times.
Okay. So did you guys end up? I know we're pulling everything up, but have you guys watched that? Did you guys watch the video from last time?
I pulled it up and I started watching it, and I'm not seeing like a share of content at all. I don't know if you guys found that. It's just dialogue.
Yeah, you have to get like 45 minutes into it. Then like the echo goes away, and then it finally starts being something I can understand. But
Oh, well, maybe I have the wrong video then, because this one's 15 minutes and 12 seconds long.
yeah, the one, I mean, I was exaggerating about 45 minutes, but this one was like
Okay.
50. It was like 50 minutes
Yeah.
was the long, but like I don't know, 30 minutes into it or so, it got pretty good. So that's probably why.
Yeah, I started it and then fell asleep. My wife woke me up and was like, "Are you going to bed? Well, what time is
There you
it?"
go.
Well, I took some 2 sentences worth of notes, and so I think we'll be good.
Okay.
Perfect.
And I also made a chart that he showed us how to make on there. So, and he said we get extra credit if we have it, so that's good.
Cool.
Excellent.
Cool.
See, I'm on the ball, guys. Sometimes I am on the ball. Sometimes I'm not.
Great. I apologize for being a slacker.
I'll go ahead and apologize for being a slacker too. At this point, though, it's not really an excuse. It's just an identity. It's who I am.
Okay. Are we go ahead to start number Are we good to go ahead and start number 3?
I'm ready.
Yep.
Okay. Sorry. So we use this data, and it says, given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept? Round to 1 decimal.
Man, y equals mx plus b. That takes me back.
It's just the 2.0. I watched a video of this before I started the class, and it talks about how when you have the setup y equals 2.0 plus or minus whatever times x, the y-intercept is the first value, so the 2.0.
So you're not a slacker, Eric. You're doing great.
There you go.
Well, yeah, I watched the simple video. I didn't watch the one where, like you said, there's that annoying echo through the first. Well, I'll say 7 minutes because I don't know what time I fell asleep while I was playing. But
the problem is one of the students has their mic. They don't have their mic muted, and so whenever the teacher talks, it like you can hear it, and it's on full blast on her computer. So
this is me saving everyone in the class from things like that. I'm considerate. I don't even show up to risk that.
It's his office hours are right in the middle of. I mean, I'm work. There's no way I can attend, so it's like I don't know. All right, so 2.0 for the first one, and then 4 is actually the 1.5 because that's the slope, is the last number. Whatever it is times x is the slope.
Yep. And this number 5 is just plugging in the value. X is going to equal 16, so a fourth of x is 4 plus -3 is 1.
1.0, right? Because we got to round to 1 decimal.
Yeah.
Okay.
1.0.
Sure.
Luckily, this is one of like the few equations that I learned that got me through high school geometry so far back in the day, and it was like tattooed to my brain.
Still is.
Yeah.
Yep.
Okay. For the next 7 questions, use the data file math self-efficiency. Be sure to use the confidence data for the explanatory variable and the score data for the response variable. Make a scatter plot for the math self-efficiency data. Use the data shapes introduced in the reading. Which shape best describes these data?
Oh, that's funny.
So we're using the quantitative inference procedures spreadsheet, right?
Yep.
Okay.
Yep.
Linear regression. Yep.
So the confidence is the explanatory.
This, my liege, is how we know the Earth to be banana-shaped.
What's the difference? I guess there, hot dog versus banana. I guess there's kind of a difference there, but
One curves up gradually. Like if you took a linear test for the first half of the data and the second half of the data, the slope would be marginally different. But not a hard angle, but a sloping curve up, which it appears this does. Albeit that's probably because of the outliers and the fact that the data is less concentrated on the left than the right, but that's neither here nor there. Still causes the same shape.
We're calling that hot dog? Banana.
Banana.
We're calling it? Okay.
so it's a banana.
I mean,
Yeah.
definitely, yeah.
Sorry, I'm just trying to clear out my data. It takes forever.
No, you're fine.
This is one of those things where if you squint at the graph, it makes more sense.
What's a hamburger shape? Would you assume round?
I think it's the one that's just kind of like all over the place and not really any form, just like a circle kind of thing.
I haven't had dinner yet. This is making me hungry.
Have your boy make you a hot pocket.
I should. Get over here, make Dad a hot pocket.
Based on the shape of the scatter plot that we produced in the last question, what can we say about the appropriateness of using simple linear regression to model this data? Well, if it is banana-shaped, then it's not going to have one predictable slope curve because it's treating it like 2 different slopes if we broke it apart that way, banana-shaped. So if simple linear regression is used for these data, the results will not be reliable, is my opinion.
Let's do it. We got 3 attempts, so one of us will get it right before we're done.
Yep.
Hopefully the professor's not watching anymore.
I mean, we would never, ever submit in sequence.
Hey, you know what? I should at least get props for watching that video where he brought that up and it was like 40 minutes in. You know, I should get props for being that far in to know that we shouldn't do that.
You're right.
It's true.
You
I
should.
would have never realized.
We should get extra credit for that.
You should.
Okay, how many observations are in the data? Is that just n?
Wouldn't it be 1? No, hang on. Wouldn't it be 2 times 50? So 100? Is that n?
That doesn't give us n.
Yeah, but how many individual observations are made? 2 variables, 50 times. Each of those variables having a different distinct value.
See, I show a count of 278. Am I off?
Wildly. Unless I didn't paste in all the data, it's entirely possible.
So math self-efficiency on here, each of the columns is 139. If you times that by 2, I don't know what that is.
278.
That's what you got?
Yeah, that's what I got.
What?
Yeah,
Where are you guys coming
278.
up with that?
If you look at the data that's in the math self-efficiency spreadsheet, and you just scroll down to the bottom, it ends at 140. So if you just subtract 1 because of the title line, it's 139. You times it by 2. In the theory that it'll be 1 or 278.
Yeah, I was looking at the wrong value. That's totally my bad.
No, you're good. What is the y-intercept?
It's 1.296.
.296. Yeah, that's what I got too.
I'm reading that slope out is 0.042 when x equals 4. Y-intercept, or rather, y is going to equal 464.
Sorry, did we already do number 10?
Yep.
The slope, yeah, because it's on the spreadsheet. It's .042.
Oh, sorry.
Oh, you're fine. So I got 1.464 for 11. That everybody else got?
Yep.
Sorry, what was that again? Sorry, my sound keeps cutting out. I didn't even know you guys were on to that question.
1.46.
So I got. Yep.
Okay, got it.
Okay.
Are you reading number 12?
Yeah. So the maximum predicted value is at 1.546, or do we need to add the confidence interval upper bound to it?
I don't know. Let me hit the book. So if you look at cell D18, that can't be right. Oh, I think I see what it's saying. So on the spreadsheet where it says the confidence prediction intervals for regression response, I just see that. And there's the blue cell. And then it defaulted to 6 for me, so I don't know if it's defaulted to 6 for you guys.
Yeah,
But I think that's where, I think that's what it's saying. if you put the scale of 1 or up to 6 in there, then it'll tell us the maximum benefit. Because you put 5 in there, it changes. If you put 6 in there, it changes. So I think all we have to do is say, okay, in this case, there's a positive correlation. We can use the largest X value, which would be 6, to find the largest predicted value of Y.
All right. So we're going to roll with 1.546.
It's either that or the 2.907, right? I don't know.
We have 3 chances, right? So might as well try
Yeah.
something.
All right.
They're saying the X is 1 through 6, and then the Y, it would be the predicted. So yeah, I think it's the 1.546.
But it's not that X is valued 1 through X. It's just that that's their confidence that they're associating. They're taking every sample and then rating it on a scale of 1 to 6 on how high their confidence is in that particular sample. So it's of the collective values of X, what's the maximum predicted value of Y? I'm thinking, in all honesty, it's either the 1.546 or that's the average prediction for a confidence of 6. But, I mean, adding the upper bound to it would get the maximum value. But whatever, I'm going to roll with 1.546 for now.
Yeah, we can see what it does.
Sacrificial lamb will find out for us.
I'll do it. Meanwhile, shouldn't there only be one explanatory independent and one response dependent in simple linear regression, 1-to-1?
Again, we have 3 people, so I don't know, but I think that sounds right to me.
Yeah, we can try one.
Okay, so
So we're doing one for explanatory independent variables, right?
Mhm.
that's what I was thinking, but by all means, could be wrong.
And then for question 14, how many response-dependent variables are present in a simple linear regression?
Yeah, I'm still thinking it's 1 because, I mean, we were given a linear regression test in data that only had one dependent and one, or rather, one explanatory and one response. It's just an X and a Y value.
Hey, sounds perfect to me.
So question 15 then. A company in South Dakota manufactured hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, lengths of the major and minor axes, meaning the company wants to predict size of all hat given the circumference. What is the response variable?
It's the size of the hat. That's the variable they're trying to predict.
So A. Because it's definitely not C, because they're already given the circumference, right?
Correct. They measure the circumference, X, to
So it has
predict
to be A.
size. Yeah.
Has to be A.
I agree.
I can submit first. We'll see how this goes.
Okay.
No, that's no bueno. Okay, so we missed a bunch.
Uh-oh.
Yeah, we got 10 out of 17 correct.
Jeez.
And that's including the first two that we invariably got right. So we missed number 6. It is not banana shaped. Huh. Who knew?
Well, did we miss all of those pretty much?
Let's see. Banana shaped. Question 7 we missed. Question 8 we missed. Question 9 we missed. 10 we missed. 11 we missed. And 12 we missed.
I know what happened. So it says, for the next 7 questions, be sure to use the confidence data for explanatory variable and score for response variable. And I think the way the data is presented, it's the opposite. So the confidence needs to be the X and the response needs to be the Y. So it's just the same things, except opposite.
Opposite, yeah.
So when you do that, it looks like it's, I don't know what shape that is. It looks maybe hot dog. I don't know. It's like a line, but it's not really bunched up like a hamburger.
Yeah, it definitely didn't have the tail like last time. So yeah, probably a hot dog.
Okay. So I'll put that. I'll be the next Turner-inner.
So we're saying hot dog.
We missed number 7, Michael, you said?
Yes.
Okay, so we went with the middle one.
Well, in this case, because I think it's the simple linear regression is appropriate. Because if it's all a hot dog shape, then then the line should be appropriate for it.
I agree. I don't really know the observation one though. It might just be 139. But
yeah, because we missed 9 or 8, right, Michael?
We missed 6, 7, 8, 9, and 10 and 11. Okay. And 12.
So, okay, so 8 we can go with
yeah, I'll try 139 and see if that's what it is.
Okay.
The y-intercept looks like it's 18.69. Is that right? Is that what you got?
18.690. Yeah, that's what I got.
Yeah, it's like the same thing except just with the other data.
What'd you get for 8 again? Sorry.
139. So we just, instead of taking 2 observations, just doing the single. So just 139. Sorry.
Good call.
That was a good explanation. Y-intercept 18.690. The slope 12.695. Is that what you guys got?
12.695. Yeah, that's what I got.
Okay. Predicted value of y when x equals 4.
Here we go. Right
Did we just change x to 4?
Yes.
Yeah.
You just plugged it right in.
69.469.
Well, make sure you change. Yeah, exactly.
Is that right? Is that what you guys got to?
Hold on. Just
But-
doing it now.
Okay.
Do we say that simple linear regression was or was not appropriate?
Yeah, we said this simply. Yeah, that one. Sorry.
It is.
It is.
Yeah, we
So
think.
it should be A. I don't know.
All right.
For me, it was A.
Number 12.
So did you get 69.47 for your 11?
I got 469 because it said round to 3 decimal places, but I don't know if that's important or not.
So 69.469.
Number 12, we missed that one too, right, Michael?
Correct. That's the last one we missed.
So
Well, it would change probably Yeah, because see now the predicted's 94.859.
If we put 6 in there, right?
Yeah.
We can try that. And then was that it, Michael?
Yep, one size of the hat because of the variable being predicted.
Okay, I'm going to go ahead and submit now if everyone's okay with that.
Okay.
Cool.
100%.
Sweet.
Woo! Excellent.
So anyways, while you guys are I don't know if you guys want to pull up the Google Doc. I'm not planning. I don't think it would be like effective really to write it up right now unless you guys think it is. But it's pretty easy. Like the way he was making it all complicated, and then he said something, and I was like, okay, this is exactly what it is. So the descriptive statistics. He was like making them answer all these questions of what's a descriptive statistic versus an inferential statistic. And then he just said something like, oh, the standard deviation is 1, and then the minimum is 1, and the median is 1. And so I just looked at the quantitative descriptive statistics spreadsheet. And so literally we just have to plug our data into the spreadsheet and then just write 2 paragraphs about the data. So like we have the histogram here, so we just need to, obviously describe the histogram. We need to, we can talk about the minimum, quartile 1, the median, standard deviation, the mean, things like that. So we can talk about the descriptive statistics, which is all in this thing. So QQ-plot is in there. So we already have those 2 in there. And then, so I don't know if that, it's pretty obvious to me. I don't think it'll be too hard. But then on the Google Doc, he was showing us how to make a box plot on here.
Okay.
And it's not like an exact box plot because there's no way to make one, but he showed us how to do it using stock prices or something. So I was going to ask for you guys' input on this graph because for these different graphs, we have to label them and things. So Michael, I don't know if that's something you could do with your expertise, but the box plot that I made, it shows like the different, like breakdowns of how our data is set up, and he said that would be extra credit if we showed that. So
Neat.
Yeah, it looks good. The box plot.
I don't know if like the labels are okay. Milk prices by gallon, various stores in Idaho is like the bottom line describing all of the data, and then Idaho milk prices at the top. So anyways, the median is that blue line. Michael, I can see you, or Eric, I can see you're in there, but the blue line is the median.
Mm-hmm.
So anyways, we just have to write up a description of these different things. Like what does it mean? The QQ plot shows that it's fairly normally distributed, but like then when you look at the histogram, you can tell it's right skewed. And then in the box plot, with there being a taller line on top, it means it also shows that it's right skewed. So we can talk about that, how like the data is right skewed, things like that.
Cool.
So, and I'm planning on doing this tomorrow morning, working on it tomorrow morning. So I can just because since I'm the main writer, I can write it up the best I know how, and then send you guys an email for you guys to look over it and add stuff and delete stuff. And Michael, if you wouldn't mind looking, working on the charts and making them look pretty and posting them better in here, except for the last one because it was like a long process to figure that one out. So
You got it.
unless there's like some different titles or something you want me to put on that, I'll probably just leave it.
No, I think it looks good.
So I don't really want to write it all up, but I think I don't know. Since I was the one that watched it, it might make more sense to do it myself, but
Whatever's easiest, man.
can edit and stuff. I'd really appreciate that.
Yeah, I can do the editing if you want.
I mean, and definitely by all means add stuff. I just want to get the basically what I'm going to be doing, hopefully, is getting the bare bones together, and then the rest can be filled in or edited, or you know, if you guys think it's fine, then we can just leave it. But
Cool. Yeah, that works.
so then we don't have to sit here for like another 45 minutes and type it up. We can just go our separate ways and have a good evening.
Cool. That works for me.
Seems legit.
All right, sounds good. So I'll just send you guys an email hopefully tomorrow sometime, maybe about midday, with that done hopefully. So
Cool.
yeah, we'll see you guys later then.
Sounds good.
All right.
See you. Everybody have a good night.
Later.
Weekend.
Bye.